You're standing at the edge of time itself, about to witness the universe's final moments and what lies beyond. 10 quintillion years. That's a 10, followed by 18 zeros. The human brain wasn't built to process timescales like this, but we're going anyway. Let's start with something familiar. 1 million years from now, Earth's continents will have shifted noticeably. Recognizable, but different. 1 billion years, the sun's luminosity increases enough to boil Earth's oceans. These timescales already dwarf human civilization. We're just getting started. At 1 trillion years, most stars have exhausted their fuel. The universe has gone dark in ways we can barely imagine. Galaxies that once blazed with billions of suns now contain only cooling remnants. White dwarfs, neutron stars, black holes. The era of starlight is over, but this represents only 0.0000001% of our journey. The mathematics here become almost meaningless. Our destination sits so far in the future that the entire current age of the universe, 13.8 billion years, is less than a rounding error. It's like comparing a single heartbeat to the entire history of life on Earth, then multiplying that disparity by a billion. So what actually happens during this incomprehensible span? First, the degenerate era begins around 10 trillion years. Stars are extinct. Galaxies have ejected most of their dead stars through gravitational interactions, leaving galactic cores dominated by supermassive black holes. The universe is cold, dark, and expanding, but it's still young compared to where we're headed. By 10 to the 15th years, 1 quadrillion, something called proton decay might begin. And I say might because we've never observed it. Protons appear stable, potentially immortal, but some theories of particle physics predict they eventually fall apart. If this happens, every atom in the universe slowly disintegrates. Matter itself becomes temporary. The implications are absolute. Everything physical you've ever known, every structure, every object, every particle, begins dissolving at the quantum level. Mountains don't erode. They cease to exist as their constituent protons decay into lighter particles and radiation. Now we're entering the black hole era, beginning around 10 to the 40th years. If protons have decayed, black holes represent the last significant gravitational structures. They dominate a universe that's become almost incomprehensibly empty. Space has expanded so much that the distance between any two objects is monumentally vast. The cosmic microwave background radiation has redshifted into effective nothingness, but black holes aren't eternal either. Stephen Hawking discovered they emit radiation through quantum effects near their event horizons. Slowly, impossibly slowly, they evaporate. A black hole with the mass of our sun takes 10 to the 67 years to disappear completely. Supermassive black holes, millions or billions of solar masses, persist far longer. The largest black holes won't evaporate until around 10 to the 100 years. We're still nowhere near 10 quintillion, not even close. Here's where things become truly strange. After 10 to the 100 years, we enter what physicists call the dark era. No stars, no planets, no black holes. Just fundamental particles drifting through expanding space. Photons, neutrinos, electrons, positrons if proton decay occurred. The temperature of the universe approaches absolute zero. Energy density becomes almost unmeasurably low. But 10 quintillion is 10 to the 19th. We haven't even discussed timescales beyond 10 to the 100 yet. What could possibly happen in a universe that's already reached maximum entropy, where no energy gradients exist to power any processes? The answer involves something deeply counterintuitive. Quantum mechanics allows for random fluctuations even in systems at equilibrium. Given enough time, truly absurd amounts of time, these fluctuations can produce organized structures purely by chance. A universe at maximum entropy should stay that way. Nothing should happen. But on timescales like 10 to the 10 to the 50 years, quantum fluctuations might spontaneously create particles, even complex structures, from the vacuum. not because of any physical process, but through pure statistical chance. We're talking about timescales so vast that describing them requires exponential notation raised to exponential notation. 10 quintillion years is incomprehensibly long, but it's microscopic compared to the timescales where quantum fluctuations might create something from nothing. At 10 quintillion years, we're witnessing a universe in the late dark era. Everything that could happen through normal physical processes has already happened. The cosmos has reached a state of near-perfect equilibrium. Temperature variations are essentially zero. Energy is distributed as evenly as possible across expanding space. What you'd see is nothing. Pure, absolute darkness. No light sources exist. No processes generate photons. The universe has become a cold, expanding void containing only the most fundamental particles, separated by distances that make intergalactic space seem crowded. But here's what makes this journey genuinely unsettling. The universe you've arrived in isn't dead in any meaningful sense. It's waiting for quantum fluctuations that operate on timescales, making 10 quintillion years seem instantaneous. The universe hasn't ended. It's entered a phase where traditional concepts of time become almost meaningless. Consider what waiting means in this context. On human timescales, waiting involves anticipation, boredom, the passage of moments. But the universe doesn't experience time. It simply exists in whatever state physics determines. At 10 quintillion years, that state is thermal equilibrium spread across incomprehensible distances. Yet physics suggests something remarkable. Even in perfect equilibrium, the fundamental uncertainty built into quantum mechanics never stops. Virtual particles continuously pop into and out of existence on timescales measured in fractions of a second. Most immediately annihilate. But given enough time, truly staggering amounts of time, these fluctuations might accidentally produce something stable. We're not talking about 10 quintillion years anymore. We're discussing 10 to the 10 to the 76 years. Numbers so large they dwarf 10 quintillion, the way 10 quintillion dwarfs a human lifetime. On these timescales, quantum mechanics predicts that random fluctuations could spontaneously generate entire structures, not through any causal process, but through sheer statistical inevitability, given infinite time. Boltzmann brains represent the most unsettling prediction. Named after physicist Ludwig Boltzmann, these are conscious entities that spontaneously form from quantum fluctuations, a random arrangement of particles that happens to configure itself into a functioning brain, complete with memories and awareness. It exists for a moment, perhaps experiences a single thought, then dissipates back into thermal noise. The mathematics are disturbing. It's vastly more probable for a fluctuation to create a single brain than an entire universe with consistent history. In the deep time beyond 10 quintillion years, these spontaneous consciousnesses might be the only things that ever happen. Brief sparks of awareness emerging from and returning to void, each convinced of a past that never existed. But let's return to the universe at exactly 10 quintillion years. What physical structures might still exist? The answer depends on proton stability. If protons are truly stable and don't decay, then certain configurations of matter could theoretically persist. Degenerate matter, like that in white dwarfs or neutron stars, might exist as cold, dark objects drifting through space. These wouldn't be stars. No fusion occurs. No light is emitted. They're essentially massive collections of degenerate matter at near absolute zero temperature, separated by distances so vast that calling them lonely seems inadequate. The space between them has expanded to dimensions that make current intergalactic distances microscopic. Imagine standing on the surface of such an object. Not that you could survive, but imagine the perspective. Absolute darkness in every direction. No stars, because stars burned out trillions of years ago. No cosmic microwave background radiation, because it's redshifted into nothingness. No light sources of any kind exist anywhere in the observable universe from your position. The temperature hovers just above absolute zero. Not precisely zero because quantum mechanics forbids that, but close enough that no meaningful distinction exists. No chemical reactions occur. No physical processes happen except the slowest quantum mechanical effects operating on timescales that make geological epochs seem instantaneous. You might expect silence, but sound requires a medium and molecular motion. Neither exists in any meaningful way. The concept of sound becomes obsolete. Same with color, texture, warmth. Every sense humans possess would register nothing because the universe has run out of contrasts to detect. This is what heat death looks like. Not a dramatic ending with explosions or catastrophic events, just the gradual, inevitable slide toward maximum entropy where nothing can happen because no energy gradients remain to power any processes. Some physicists propose that even heat death isn't final. Roger Penrose's conformal cyclic cosmology suggests the universe might reset somehow, that the far future and the Big Bang might be mathematically equivalent states. When all mass has decayed and only massless particles remain, time itself becomes meaningless, and the universe could transition into a new beginning. But at 10 quintillion years, we're nowhere near that hypothetical transition. We're in the thick of heat death, experiencing the universe in its most entropic state. Everything that could burn has burned. Everything that could decay has decayed. Everything that could cool has reached equilibrium temperature. What makes this future particularly haunting isn't just the emptiness, it's the permanence. The universe isn't going to suddenly reverse course. Entropy only increases. The second law of thermodynamics permits no exceptions. Every moment that passes makes the cosmos slightly more disordered, slightly more uniform, slightly less capable of supporting anything interesting. The stars you see tonight represent borrowed time. They're temporary arrangements of matter that happen to release energy through fusion, creating brief pockets of complexity in a universe sliding toward simplicity. In 10 quintillion years, that temporary phase has ended completely. What remains is the baseline state, the default configuration that matter assumes when left alone for incomprehensible periods, and that state is darkness, cold, and separation stretched across dimensions that reduce our current universe to a single point of origin. The mathematical certainty of heat death raises an uncomfortable philosophical question. If the universe inevitably arrives at this state, does anything we do actually matter? Every achievement, every creation, every moment of human consciousness exists in the brief flash before eternal darkness. The pyramids will be dust. The continents will have eroded and reformed countless times. The sun will have expanded and consumed Earth. And still, we'll be nowhere close to 10 quintillion years. Some find comfort in the idea that meaning doesn't require permanence. A song doesn't need to play forever to be beautiful. A relationship doesn't need to last eternally to be meaningful. The temporary nature of existence might be precisely what gives it value. But there's a difference between temporary and utterly erased. Heat death doesn't just end things, it eliminates every trace that anything ever happened. Information theory offers a darker perspective. According to Leonard Susskind's work on black hole thermodynamics, information might be preserved somehow in the universe's structure. But preserved for what purpose? If nothing exists capable of accessing or interpreting that information, preservation becomes meaningless. It's like saving every book ever written in a language nobody will ever speak again, then burying them where nobody will ever look. The timeline itself becomes almost incomprehensible when you try to grasp it. Humans have existed for roughly 300,000 years. Civilization for about 12,000. The entire span of recorded history fits into a period so brief compared to 10 quintillion years that mathematical notation struggles to express the ratio. If the universe's current age were compressed into a single year, human civilization would occupy the last tenth of a second before midnight on December 31st. Now extend that calendar to 10 quintillion years. On that scale, the entire era of stars existing in the universe from the first ones forming to the last ones dying, occupies less time than a single heartbeat. Everything we consider cosmologically significant happens in a flash, then the universe spends the vast majority of its existence in heat death. Quantum mechanics introduces one final disturbing possibility. Vacuum fluctuations occur constantly at microscopic scales. Particles and antiparticles pop into existence, then annihilate moments later. These fluctuations continue even in heat death. Given infinite time, or something approaching it, these fluctuations could theoretically produce anything. A random arrangement of particles could spontaneously form a human brain, complete with memories of a life that never happened. This Boltzmann brain would exist for an instant in the void, convinced of its reality, then dissipate. In a universe that's reached heat death, such random formations might be the only remaining form of consciousness. Brief, isolated, delusional moments of awareness flickering in the darkness. The probability of such formations is astronomically low, but across the timescales of heat death, low probability becomes near certainty. The universe might spend eternity generating random conscious moments, each one appearing and vanishing without context or continuity. Your consciousness, right now, reading this, could be one such moment. You could be a random fluctuation in a dead universe, experiencing a false memory of being human, living in a civilization that never existed. There's no way to disprove this. No test can distinguish between genuine, continuous experience and a spontaneous arrangement of particles that happens to encode convincing memories. This possibility makes heat death even more unsettling. It's not just the end of meaningful existence, it's the replacement of genuine consciousness with infinite false starts. The universe continuing to accidentally create awareness, then erasing it over and over across timescales that make eternity seem brief. Perhaps the most honest response to heat death is acceptance without surrender. Yes, the universe trends toward maximum entropy. Yes, everything ends. Yes, on cosmic timescales, human existence barely registers. But you're here now. Consciousness exists. The universe has arranged itself into patterns complex enough to contemplate their own existence, and that remains remarkable regardless of how long it lasts. The stars will die. The galaxies will drift apart. Heat death will arrive exactly as thermodynamics predicts. But between now and then, there's this: the temporary arrangement of matter that allows thought, feeling, and meaning to exist. Not forever, but for now. And now is all consciousness has ever had anyway. In 10 quintillion years, the universe will be dark, cold, and empty. Every star will have exhausted its fuel. Every black hole will have evaporated. Space will have expanded beyond any hope of reversal. But that's 10 quintillion years away. Right now, stars are forming. Planets are orbiting. Life is evolving. Consciousness is experiencing itself. The universe is young enough that interesting things still happen. That window is temporary, but we're in it. The journey to 10 quintillion years reveals something profound about existence itself. We live in an impossibly rare moment when the universe supports complexity, consciousness, and wonder. Heat death isn't a failure of the cosmos. It's the inevitable destination of entropy, as certain as mathematics itself. Every star you see tonight is burning on borrowed time. Every thought you have exists in defiance of the universe's march toward equilibrium. That doesn't diminish their value. It amplifies it. We're not watching the universe die. We're experiencing its brief, brilliant moment of being awake.